Artificial intelligence, or in short AI, has a long and rich history that dates back to antiquity. Stories, myths, and rumors have been told about artificial beings endowed with intelligence or consciousness by skilled craftsmen. Philosophers also contributed to the development of AI by attempting to describe human thinking as the mechanical manipulation of symbols. The advent of the programmable digital computer in the 1940s marked a significant turning point in the history of AI. This machine was based on the abstract essence of mathematical reasoning and inspired scientists to explore the possibility of building an electronic brain. The field of AI research was established in 1956 at a workshop held in Dartmouth College in the USA. The attendees of this workshop went on to become leaders in the field of AI research for many years. At the time, many experts predicted that a machine as intelligent as a human being would be developed within a generation, and they were provided with substantial funding to achieve this goal. However, as time passed, it became evident that commercial developers and researchers had underestimated the difficulty of the task. In 1974, due to criticism from James Lighthill and ongoing pressure from Congress, the US and British governments halted funding for undirected research into AI. The years that followed were known as an AI winter. Despite this setback, interest and investment in AI eventually returned. In the 21st century, the application of new methods, powerful computer hardware, and immense data sets to machine learning have allowed AI to successfully solve many problems in academia and industry. The concept of artificial intelligence is based on the idea that human thought can be replicated through mechanical means. This idea is rooted in the study of mechanical or formal reasoning, which has a long and storied history. As far back as the first millennium BCE, philosophers from China, India, and Greece developed structured methods of formal deduction. Over the centuries, their ideas were refined and built upon by philosophers such as Aristotle, Euclid, Al-Khwarizmi, William of Ockham, and Duns Scotus. In the 13th and 14th centuries, Spanish philosopher Ramon Lull developed logical machines that were dedicated to producing knowledge through logical means. Lull's machines were described as mechanical entities that could combine basic and undeniable truths using simple logical operations. These machines were capable of producing all possible knowledge through mechanical means. Lull's work had a significant impact on Gottfried Leibniz, who later developed Lull's idea further. Leibniz, Descartes, and Hobbes explored the idea in the 17th century that rational thought could be as systematic as algebra or geometry. This idea led to the physical symbol system hypothesis, which became the guiding faith of AI research. In the 20th century, the study of mathematical logic provided the essential breakthrough that made AI seem plausible. Boole's The Laws of Thought and Frege's Begrafschaft laid the foundations, while Gödel's incompleteness proof, Turing's machine, and Church's lambda calculus answered Hilbert's question about whether all mathematical reasoning could be formalized. Russell and Whitehead's Principia Mathematica provided a formal treatment of the foundations of mathematics, inspiring these breakthroughs. The mathematicians Gödel and Turing showed that mathematical logic had limitations, but within those limits, any mathematical reasoning could be mechanized. This was thanks to the Church-Turing thesis, which suggested that a simple device like a theoretical Turing machine could imitate any possible process of mathematical deduction by manipulating symbols. This insight inspired a few scientists to consider the idea of creating thinking machines. A group of scientists from different fields, including mathematics, psychology, engineering, economics, and political science, began discussing the possibility of creating an artificial brain in the 1940s and 50s. This led to the establishment of the academic discipline of artificial intelligence research in 1956. The idea of creating thinking machines emerged in the late 1930s to early 1950s, influenced by recent research in neurology, cybernetics, information theory, and computation theory. This led to the development of robots such as W. Gray Walter's Turtles and the Johns Hopkins Beast, which were controlled by analog circuitry. In 1943, Walter Pitts and Warren McCulloch introduced the concept of neural networks by analyzing idealized artificial neurons and demonstrating how they could perform simple logical functions. Marvin Minsky, a graduate student inspired by their work, built the first neural net machine in 1951 with Dean Edmonds. Minsky went on to become a prominent figure in AI for the next 5 decades. Alan Turing's 1950 paper on the possibility of creating thinking machines was a groundbreaking work that introduced the famous Turing test. Turing acknowledged the difficulty in defining thinking and proposed that if a machine could hold a conversation indistinguishable from that of a human, then it could be considered thinking. This simplified version of the problem allowed Turing to convincingly argue that a thinking machine was plausible, and he addressed common objections in his paper. The Turing test became the first significant proposal in the philosophy of artificial intelligence. Christopher Strachey and Dietrich Prinz created checkers and chess programs respectively, using the Ferranti Mark I machine of the University of Manchester in 1951. Arthur Samuel later developed a checkers program in the mid-1950s to early 60s that eventually became skilled enough to compete with a reputable amateur player. The progress of the game AI would be used as a benchmark for measuring the advancement of AI throughout its development. In 1956, Marvin Minsky, John McCarthy, Claude Shannon, and Nathan Rochester of IBM organized the Dartmouth Workshop. The proposal for the conference stated that every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. Key participants at the conference included Ray Solomanoff, Oliver Selfridge, Trenchard Moore, Arthur Samuel, Alan Newell, and Herbert A. Simon, who all made significant contributions to AI research in its early years. Newell and Simon debuted the Logic Theorist program at the conference. McCarthy convinced attendees to adopt artificial intelligence as the field's name. The 1956 Dartmouth Conference is widely regarded as the birth of AI, as it gave the field its name, its mission, its first success, and its most important players. McCarthy chose the term artificial intelligence to distance the field from cybernetics and the influence of Norbert Wiener. During the 1980s, corporations worldwide started adopting a type of AI program known as expert systems. Knowledge became the main focus of AI research. During this time, the Japanese government funded AI aggressively through its fifth-generation computer project. In the early 1980s, connectionism was revived through the work of John Hopfield and David Rumelhart, which was another promising development for AI. As a result, AI saw significant success during this era. Expert systems gained popularity in the 1980s due to the expert knowledge they possessed. This was part of a new direction in AI research that had been emerging since the 1970s, where researchers realized that intelligent behavior was heavily reliant on the ability to use vast and diverse knowledge in various ways. Knowledge-based systems and engineering became the focus of AI research in the 1980s, as noted by Pamela McCorduck. The birth of SICK in the 1980s was also significant, as it was the first to attempt to address the problem of common-sense knowledge directly by creating a massive database that contained all the mundane facts that an average person knows. In 1989, chess-playing programs High-Tech and Deep Thought, both developed by Carnegie Mellon University, defeated chess masters. This success paved the way for the development of Deep Blue. From 1993 to 2011, AI finally accomplished some of its earliest goals after being around for more than half a century. It is utilized successfully in the technology industry, although it wasn't always widely acknowledged. This progress was made possible by advancements in computer power, as well as by concentrating on specific isolated problems and pursuing them with scientific rigor. Nevertheless, AI's reputation in the business world remained somewhat tainted. Within the field, there was no consensus on why AI had failed to achieve the dream of human-level intelligence that had captured the world's imagination in the 1960s. As a result, AI became fragmented into competing subfields that focused on specific issues or approaches, sometimes even using new names to hide the discredited artificial intelligence label. Overall, AI was more successful and cautious than ever before. In the 21st century, big data, cheaper and faster computers, and advanced machine learning techniques were successfully applied to many problems across the economy. McKinsey Global Institute estimated that nearly all sectors in the US economy had nearly 200 terabytes of stored data by 2009. The market for AI-related products, hardware, and software reached over $8 billion by 2016. And deep learning techniques drove progress in various fields, such as image and video processing, text analysis, and speech recognition. However, deep learning has problems of its own, such as the vanishing gradient problem. Big data refers to a collection of data that requires new processing models due to its volume, velocity, variety, value, and veracity. The strategic significance of big data technology is to specialize in meaningful data and realize its value through processing. Over the past years, AI has rapidly advanced and made significant strides in various fields, From natural language processing to image and speech recognition, AI has shown incredible potential in solving complex problems and making significant contributions to society. One of the most exciting recent developments in AI is the creation of generative models, such as GPT-3, Midjourney, and DALL-E. These models use deep learning algorithms to generate new content, including text, images, and videos that closely mimic human-created content. These models have the potential to revolutionize various industries, such as fashion, advertising, and entertainment, by enabling designers and creators to generate new and unique content quickly and efficiently. Furthermore, AI is being used in healthcare, climate science, and other areas to tackle some of the most pressing challenges facing humanity. We're excited to see what the future holds for AI. The potential applications of AI are vast, and the technology has already made significant progress in solving complex problems and improving our lives. With continued research and development, AI has the potential to transform numerous industries, solve global challenges, and unlock new opportunities we have yet to imagine. What are your thoughts about AI? Write them down in the comments.